Okay, some more work with identities, getting a little bit more detailed here. Notice here we have a couple, three techniques to help us out here, some ideas to get started. But again, there's no one set way to start each problem. So running through these pointers real quick. If one side of an identity contains a sum or difference of two functions, find the least common denominator and perform the indicative operation. Done a lot of this so far, find the least common denominator. So if we have 1 over cosine plus 1 over sine, I hope we've all established our common denominator would be cosine times sine. Then we would have sine plus cosine as our numerator, make that one fraction. So that idea, find our common denominators, make it a single fraction, and then work from there. Number two, if one side consists of several terms over a single denominator, try breaking the fraction into sum of fractions. This is the opposite suggestion number one. Let's say we have cosine plus sine all over, we'll say sine, and we want to simplify that, so the other direction is to take and write that as two separate fractions, cosine over sine plus sine over sine, which would become cotangent plus 1, cosine over sine being cotangent and sine over sine being 1. So there's breaking one fraction into two separate fractions to simplify or come up with a possible proving of identity. And then finally here, factor all terms that can be factored. Basically, we've done three things with factoring. First one is find a greatest common factor. So if two items have something in common, let's say 2x plus 6, we can factor out a 2 and have x plus 3. Same idea applies to our trig functions. That should honestly be the first step you do in a factoring problem. Look for a greatest common factor. From there, we factor the difference of two squares. So if we had, I'll go with the algebra version, x squared minus 4, that would factor to be x plus 2 times x minus 2. Then our third factoring technique we've looked at is working with our trinomials, and that's essentially reversing that FOIL process. Okay, so we saw a couple of those trinomials with three terms in there. If we have x squared plus 5x plus 6, we reverse the FOIL process to blank sets of parentheses. To get x squared, we multiply x times x. To get 6, we multiply 3 times 2. Since we want a positive 6 here and a positive 5, 3 plus 2 equals 5, so they should both be positive. So we've reversed the FOIL process. So those are some suggestions maybe to get us started. Not all inclusive by any means, but it gives us an idea of some things we can do. So we'll start here with example number 1. You can read through here, sine over 1 minus cosine, minus 1 plus cosine over sine is going to simplify down to 0. As we start here, we would start probably by finding a common denominator. And that common denominator would be sine times 1 minus cosine, which means my first fraction would need to be multiplied by sine. So our top sine times sine is sine squared. I'm going to go ahead and write out the top. The 1 plus cosine should then be multiplied by 1 minus cosine. We still have the same denominator through here, sine times 1 minus cosine. And my sine squared is not going to change for now, but I wanted to show how we multiply these two together. So these two, we would FOIL. If we recognize the pattern, these two terms are called conjugates. Conjugates, when we multiply in the FOIL process, the outer and the inner cancel each other out, so I can just do first and last, which is what I'm going to do. So 1 times 1 is 1, and cosine times negative cosine is minus cosine squared. Noting that I'm leaving that in parentheses because of this minus sign. Anything I have a product or I'm going to subtract there, I have to subtract every single term that's there, not just the first term. So parentheses remind me to do that. So continuing on, we have sine times 1 minus cosine in our denominator. Moving back to our numerator, I'll leave the sine squared, but hopefully we recognize from our identities that 1 minus cosine squared here is sine squared. So I'm going to use one of our identities to put in there. In place of 1 minus cosine squared, we put sine squared. And now you should notice in our numerator, sine squared minus sine squared winds up being 0. And 0 over anything is going to be 0. So we've proved that it does equal 0. And that would be our first problem there. We'll now move on to another example. 3 minus 4 sine plus sine squared over cosine squared is going to equal 3 minus sine times 1 plus sine. Now as we move through here, we want to keep an eye on what we're trying to get to. So noting on my left-hand side I have a single fraction, on the right-hand side I have a single fraction. So I'd probably like to keep that single fraction all the way through there if at all possible. I then take a closer look, and maybe the first thing I would do is this side's in terms of sines, but I have a cosine squared over here. So let's start out by changing that cosine squared to be in terms of sine squared, and cosine squared as a Pythagorean identity is 1 minus sine squared. From here, it appears we have some factoring we can do. My numerator is a trinomial, so I'm going to set up 2 blank sets of parentheses and reverse the FOIL process. So the first term in my parentheses are what I multiply together to get 3. That should be pretty simple. 3 times 1 gets me 3. The last terms in my binomials, or my blank parentheses here, are what I multiply together to get sine squared. And then again, should be pretty easy, sine times sine. Now, with that being sine times sine, to get a positive sine squared, I could take a positive sine times a positive sine, or a negative sine times a negative sine. In this case, I want to keep track of the fact that I want to have a negative 4 sine in the middle, so my outer and my inner products should add to be negative 4, which should tell me or alert me that both of these should be negative. Outer terms negative 3 sine, inner terms negative 4 sine, or negative 1 sine, sorry, and negative 3 plus negative 1 is negative 4. So we have factored that down to our 2 binomials. Kind of making a mess here, but I'm trying to get rid of those brackets so we can clean it up a little bit. So we have 3 minus sine times 1 minus sine. And then we'll go ahead and move over to our denominator as well. 1 minus sine squared is one of our other factoring techniques. 1 and sine squared are both perfect squares. The difference of 2 squares, 1 minus sine and 1 plus sine. Now, between our numerator and denominator, we have common factors that we can cancel. Between the numerator and denominator, we cancel 1 minus sine. Those cancel out, and we're left with 3 minus sine over 1 plus sine, which was where we were trying to get to. So we have proved yet another identity. We've got 3 more we're going to run through here fairly quickly. Top one here, cosine over cotangent minus sine over tangent is going to equal sine minus cosine. We have a couple different approaches to make here. What a lot of people like to do is change the sines and cosines right off the bat. So I'm going to change cotangent to be cosine over sine. And I'm going to change tangent to be sine over cosine. So notice in both cases we're dividing our terms by a fraction, and when we divide by a fraction we multiply by the reciprocal. So cosine is going to be multiplied by the reciprocal of this fraction right here, and the reciprocal of that fraction is going to be sine over cosine. I'll go ahead and write out the other one as well. So minus, and this sine here is also going to be multiplied by a reciprocal, the reciprocal of this fraction. So I'll multiply by the reciprocal, which is cosine over sine. So now maybe just for visual effect, I'll put this over 1. We're multiplying 2 fractions together. When we multiply, we can cancel numerators with denominators, cancel the signs over here, and you can see what's left in our first term. 1 times sine over 1 times 1 is simply sine. 1 times cosine over 1 times 1 is minus cosine, and there is our identity. Let's just keep moving along here. We have cosecant minus sine over 1 plus cosine is going to equal cotangent. I would begin by changing everything in terms of sines and cosines. So my cosecant is 1 over sine. And I'll leave my other fraction as it is because it's already in terms of sines and cosines. 2 separate fractions. I want to get to a single term, so I want to go ahead and find a common denominator. which is sine times 1 plus cosine. Making a side note here, probably should have made it earlier. If I have a denominator that contains 2 or more factors, I say leave it in factored form if you have different functions. So notice I have a sine and cosine, 2 different functions. If these were all sines or all cosines, I might go ahead and multiply those together. But we're going to leave that denominator in factored form. My first numerator, 1, has to be multiplied by 1 plus cosine. So 1 plus cosine is that numerator. And sine has to be multiplied by sine, so I have minus sine squared. Now, a simple mathematical technique here. I'm going to leave my common denominator as it is. But I can add 2 terms together in whatever order I want. 3 plus 4 is the same thing as 4 plus 3. So I'm just going to flip-flop these first 2 terms and do cosine plus 1 instead of 1 plus cosine. Not that it's a big deal, but it does help me in seeing now that at the end of my numerator, I have 1 minus sine squared here, which should look familiar to me. It is a Pythagorean identity of cosine squared. So I've replaced 1 minus sine squared with cosine squared. And we still have that over our common denominator, sine times 1 plus cosine. We apply one of our factoring techniques now. Notice our numerator has a common factor of cosine, so I'm going to factor that cosine out. That leaves me with 1 plus cosine as my numerator, or my other factor. Still over my common denominator of 1, or sine times 1 plus cosine. Since they're written straight up and down there, I hope we all can see that our common factors of 1 plus cosines cancel each other out. So we're left with cosine over sine, which just so happens to be our cotangent. So we've proved yet another identity. One last time as practice, we have some opposite angle identities in here. It appears 1 minus cosine of negative x over sine x minus sine negative x over 1 minus cosine is going to equal to 2 cosecant. So I would suggest starting out with our opposite angles and simplifying down there. So my first one, cosine of negative x as an identity just equals the cosine of x. Essentially the negative sign can disappear. Sine of negative x, oops, let's try that again. Sine of negative x from our identity sheet equals negative sine of x. I'm going to make that replacement negative sine of x over 1 minus cosine. And now you notice we have back-to-back minus signs here. It's always easier, I think, when we have fewer operations to deal with, fewer signs to keep track of. So minus and negative will make that a plus sine over, over 1 minus cosine. Okay, so 2 quick steps to simplify that. Our opposite angles. From here, we'll go to a common denominator. My common denominator is 1 minus, or sine times 1 minus cosine, which means the 1 minus cosine that's already up here has to be multiplied by the 1 minus cosine that it's missing in the denominator, and the sine that's up here has to be multiplied by the sine that's missing to get sine squared. So I'm going to go ahead and FOIL my numerator, 1 minus cosine times 1 minus cosine. Again, there's a shortcut version of that. 1 minus 2 cosine plus cosine squared. Again, we went ahead and FOILed that, but because they have the same 2 terms in the same operations, the outer and the inner are the same, so I just doubled those. 1 times negative cosine was negative 1 cosine, so I doubled that to get negative 2 of those. I still have the plus sine squared on the end of that, and that's over my common denominator of sine times 1 minus cosine. If we take a look at our numerator, our last 2 terms there should look familiar to us. Sine or cosine squared plus sine squared is 1. So in place of those 2 terms, I'm going to replace that with what it equals of 1. Still over my common denominator is sine times 1 minus cosine. Combining like terms, 1 plus 1 is 2 minus 2 cosine over my common denominator of sine times 1 minus cosine. As we continue to move on, my numerator has a greatest common factor of 2. So I'm going to factor 2 out of both terms. 2 times 1 minus cosine over sine times 1 minus cosine. And it's always nice when we see how those things line up. The 1 minus cosines are going to cancel. And I'm going to write this in two parts. I have 2 times 1 as my numerator, and sine times 1, or 1 over sine, as my denominator. I'll write that as two separate products just so we can see how that becomes 2 cosecant, because 1 over sine is cosecant. So there is our identity of 2 cosecant. So notice with a lot of algebra work involved there, we had some factoring, we had some common denominators, and a few identity changes to make as we go through there. So a combination of those identities and our algebra skills.